And in today's episode, among other things, you'll see Elon Musk announces the start of production of 1 million units of the Optimus robot. China presents a realistic humanoid with empathy that is created to support mental well-being. Androids at school. The humanoids are now taking over the classrooms. In the United States, the robot Figure 03 has finally arrived at BMW factories, the first store in the world 100% managed by a single humanoid robot. This is already a reality in China. Let's dive into all that and a few more new tech developments. Hello everyone, I'm Carlos Alves and you're watching Incredible Reality. And the Chinese giant Robotic has presented its newest model of humanoid robots called U-World U1. The model was developed to become a companion, capable of interacting naturally with humans, understanding our emotions, and offering support. In a world increasingly marked by social isolation, the aging population and the growing number of people living alone have created a challenge that goes far beyond technology. With that in mind, instead of focusing solely on physical automation, robotics companies have already started investing in what's called effective computing, a field that combines artificial intelligence, natural language, emotion recognition, and social interaction. To make this interaction convincing enough, Robotic developed a mechanical architecture that is extremely sophisticated. The robot has 88 degrees of freedom distributed throughout its body, allowing it to naturally reproduce movements of the head, arms, hands, torso, and body language. One of the main highlights is its biomimetic cervical spine with a double pivot, which provides smooth and very natural movements, so to speak, during conversations, helping reduce the rigid look typical of traditional robots. And, on top of all that, the facial system synchronizes lip movements with speech, and it happens in just a few milliseconds. This way, the dialogue becomes much more fluid and reduces that sense of artificiality during the interaction. But what really sets U1 apart is its software. Instead of just responding to the content of the words, its artificial intelligence was trained to interpret emotional signals throughout the entire conversation. The architecture combines quick responses to keep the dialogue natural, while the robot is actually performing deeper analyses in the background. According to the company, the system can identify more than 20 different emotional states using information such as the context of the conversation, tone of voice, and interaction history. All of this is managed by the so-called Memory OS agent, a persistent memory platform that allows the robot to remember previous conversations, recognize users' references, and build an increasingly personalized relationship. Over time, as it spends more time with humans naturally, a technology like this raises a lot of serious concerns about our privacy, right? After all, a robot designed to provide companionship will inevitably have access to extremely personal information. To face this challenge, Robotic claims to have developed an architecture based on multiple layers of protection, which prioritizes local processing whenever possible, thus reducing dependence on cloud computing. In this way, sensitive data related to conversations with the human user can remain stored on the device itself, thus offering the user greater control over their information. Although it's still too early to say that robots will be able to replace human therapists, family members, or genuine human relationships, the direction of technology is also quite clear, isn't it? Each new generation of humanoid robots is moving beyond an exclusive focus on mechanical strength and is also investing in so-called social intelligence. If before the goal was to build machines capable of working with us human beings, now the challenge is to create machines capable of living alongside us. Yes, that's already happening, you see. And Elon Musk's boldest plan, to reshape the global workforce by manufacturing 1 million units of the Optimus robot, has just gained an execution schedule that is relentless. Tesla stated that the time has come to turn this vision into mass production. During the 2026 Global Digital Economy Conference, Tesla's Vice President, Grace Tao, confirmed that the company really intends to start large-scale manufacturing. Assembly lines at the Fremont Gigafactory are already running at a very intense pace to produce electric vehicles. And now they need to accommodate a completely different product. And this requires reorganizing supplier chains, developing new industrial processes, and leveraging humanoid robotics. This same philosophy that made Tesla the benchmark for automated car manufacturing. Reduce parts, simplify components, and produce in huge volumes to bring down costs. And this strategy explains the evolution of Optimus itself. In just a few years, the project went from the famous presentation with an actor in costume dancing on stage next to Elon Musk, to prototypes capable of walking, organizing objects, handling delicate fabrics, and performing basic industrial tasks. Much of this progress came from hardware standardization, more compact electromechanical actuators, integrated computer vision systems, and a simplified mechanical architecture. All of this was developed to facilitate mass production. The fewer different parts there are and the greater the repeatability of the components, the more efficient the production line becomes. But perhaps Tesla's most ambitious goal isn't technological, but economic. Elon Musk says he intends to sell the Optimus robot for less than $20,000 a price, much lower than the current cost of most experimental humanoid robots in the world today. To reach this price, the company is betting on mass production. The greater the volume produced, the lower the unit cost of each robot tends to be. Musk even stated that in the long run, the robotics division could generate much more revenue than Tesla's entire electric vehicle operation, turning Optimus itself into a new automation platform for factories, logistics centers, and in the future, our homes. Naturally, there are still major challenges ahead, aren't there? Producing a few thousand robots is very different from manufacturing hundreds of thousands or millions of units while maintaining quality, reliability, and low cost as he promised. Furthermore, the timelines announced by Elon Musk have historically been much more optimistic than the actual pace of project development. Even so, my friends, the simple fact that Tesla is already discussing industrial targets of this magnitude shows that humanoid robots are indeed starting to leave the laboratories and are definitely entering the planning of major global production chains. The question that remains is this: are we really witnessing the birth of the largest robotic workforce in history? Or are we just facing another one of Elon Musk's timelines that will take much longer than he promised? So, what do you think? I think we really are at least getting started because he's been talking about this for quite some time, right? At least it's already getting started. And you tell me here in the comments, okay? That really helps the channel a lot. In the last few decades, technology has definitely entered the classrooms, but in the form of computers, tablets, and even digital whiteboards. But now, a new chapter is beginning, okay? For the first time in history, a school district in the United States has decided to integrate a full-sized humanoid robot into the school environment to work as a teacher's assistant and student tutor. The project is taking place in Salamanca in the state of New York and represents one of the most ambitious experiments ever carried out in education. Of course, with artificial intelligence incorporated, the modern educational system was conceived over a century ago. The idea was to meet the needs of the Industrial Revolution. However, the current reality is completely different. Students deal daily with artificial intelligence, social networks, and instant information, while schools are struggling to personalize learning and keep students engaged in the classroom. It was in this context that the Salamanca district approved investment to test this new approach. The stated goal is not to replace human teachers, at least not at this initial stage. For now, the idea is to use humanoid robots as a complementary teaching tool, capable of answering questions, reinforcing the material, and providing individualized support during and after classes. The robot belongs to the M-series line from Robotics and was developed to have a friendly appearance, thus making social interaction easier. Outside of class hours, students still have access to the assistant to answer questions, review exercises, and reinforce learning at any time of the day. So, what do you think about this use of robots? Do you approve, or do you think it's a bad, dangerous idea? Or is everything fine? Remember what I always say around here, right? Commenting not only boosts the video's reach, but YouTube also recommends more videos from the channel, seeing that you like the content. So please help me out. And what would happen if one of the most valued and also strategic professions of the past decade was suddenly obliterated by an artificial intelligence capable of working 38 times faster than top-tier human teams? In an experiment that shook the foundations of the technology market, Androth, which revealed that its new language model controlling a physical robot, solved complex software engineering tasks in just 9 minutes. In the so-called FET project, Claudio was given access to the complete robot development environment. This way, he could analyze information, write programs, run tests, identify failures, and make corrections automatically. In other words, he started acting as a true engineering agent, capable of completing entire development cycles practically without any human intervention. The secret to this speed is the agentic architecture. Instead of producing just one response and waiting for a new instruction, the system operates continuously in a cycle of observation, planning, execution, and validation. At each step, it checks if the code actually works, identifies possible errors, and automatically modifies its strategy when necessary. For example, during testing, Claudio was able to locate libraries capable of controlling sensors and integrating cameras and systems. He also handled, of course, programming computer vision algorithms and calibrating the robot's movement while correcting the issues that arose throughout the process. All of this autonomously, my friends. The most impressive aspect is that this capability was not developed exclusively for robotics. According to Anthropic, it is an emergent ability of the most advanced artificial intelligence models. As these systems become more capable of reasoning, understanding context, and performing tasks in sequence, they naturally start to solve increasingly complex problems. And this completely changes the role of software engineers. Instead of writing every line of code manually, the professional now sets goals, supervises results, validates solutions, and guides the artificial intelligence during much larger projects. And this means that programmers are going to disappear. Most likely not for now, right? But the profession is certainly entering a new phase, just like when calculators arrived. That didn't put an end to mathematicians, and CAD software didn't eliminate engineers. Artificial intelligence is likely to profoundly transform the way software development happens. But it probably won't eliminate this profession, will it? Will it? Humanoid robots are definitely leaving the laboratories to take on roles inside the biggest factories on the planet. BMW took another step in this transformation by expanding its partnership with Figure AI and now starting the integration of the new generation of Figure 03 robots in its operations in the United States. Equipped with artificial intelligence, advanced computer vision, and a set of sensors distributed throughout its body, this robot was designed to perform logistical tasks continuously, side by side with human workers. This collaboration between BMW and Figura began with a pilot project back then, using the Figure 02 at the Spartanburg factory in South Carolina. For approximately 10 months, the robot took part in activities related to supplying welding cells and also moving components used in the manufacturing of the BMW X3. The very positive results encouraged a new stage of the project. And now, the focus is no longer just on production, but has shifted to internal logistics, one of the most critical sectors in any modern factory where delays of just a few minutes can interrupt an entire assembly line. And Figure 03 was developed precisely to operate in this dynamic environment. Its hands incorporate high-precision tactile sensors and integrated cameras in the palms, allowing it to identify objects, confirm their position, and automatically adjust the force that is applied. During handling, the robot's external structure received soft coverings to reduce risks during shared work with human operators, while the induction charging system eliminates the need to connect cables manually, increasing the time available for continuous operation. But the hardware is just the visible part of this innovation. Even before the robot starts operating, its entire routine is digitally simulated using the BMW iFactory platform. In this virtual environment, engineers test trajectories, identify logistical bottlenecks, and adjust movements to reduce unnecessary travel. At the same time, AI-based systems continuously monitor the ergonomics of tasks, directing the humanoid robots to repetitive and physically demanding activities. Meanwhile, the automated inspection platforms monitor production quality in real time. This advancement by BMW shows that the next industrial revolution might not be marked only by much faster assembly lines, but rather by silicon workers capable of learning, seeing, manipulating objects, and collaborating directly with us, human beings. The era of artificial intelligence has begun, my friends. That's a fact. And the factories of the future will be less and less defined by fixed machines and more by humanoid robots walking back and forth. Inside these factories, making the products we'll use, and according to them, they'll be really cheap, right? Let's wait and see. And there in China, a local manufacturer decided to expose its humanoid machines to the biggest challenge possible: a real production line. Working in front of the cameras for several days in a row, the results surprised even the experts. After a week of continuous operation, the robots achieved a 99% success rate in performing industrial tasks. And this fact demonstrated that physical AI is beginning to reach a new level of maturity. To prove that their systems were ready for this scenario, Jibo did just like the figure in the United States did, broadcasting live the operation of its robots in an electronics factory in Nanshan, this way eliminating any suspicion of carefully prepared demonstrations. During the test, the fleet accumulated more than 64 hours of continuous work, performing 64,828 operations in 4 distinct industrial workflows. Throughout this period, the robots participated in the production and inspection of 17,626 products according to the company, maintaining a success rate close to 100. Much of this performance comes from the Jibo G2, a mobile manipulator that combines humanoid arms with a wheeled base, increasing movement speed without compromising production and precision. Equipped with edge computer vision, the robot identifies micro defects in electronic components and automatically adjusts the applied force to handle delicate parts without causing any damage. The results also reflect the speed at which the company is expanding its production capacity. According to Jibo, the jump from 5,000 to 10,000 humanoid robots manufactured took only 3 months to happen, a pace much faster than what was seen in the first generations of the platform. With this, the Chinese company is already among the world leaders in the humanoid robot sector, and it reinforces the trend that these robots are really moving from experimental projects to becoming industrial equipment for large-scale production. And this supports Elon Musk's view. I think the guy's telling the truth, huh? We'll have to wait and see, but also watch what's happening in China. Look at this. Imagine walking into a convenience store and realizing there isn't a single human employee working there. There's no cashier, no stocker, no manager, not even a single attendant. The only humanoid robot greets customers, organizes the shelves, manages inventory, processes payments, and keeps the whole operation running by itself. And if you don't pay, it has to chase after you. Also, I don't know, not really. Holbot decided to eliminate that middleman. With support from the Hong Kong State Innovation Fund, the company opened a new pilot store that's completely run by a single humanoid robot. The goal isn't just to reduce operational costs, but to find out how far an embodied artificial intelligence can take over physical decision-making. In a real commercial environment, where customers come and go all the time, products change places, and each interaction requires different responses. At the center of this operation is the robot Xiaogao. Its structure was specifically designed to work in small establishments. Combining long-reaching arms with an extremely precise manipulation system, its robotic hands automatically adjust the applied force to pick up anything from light snack packages to rigid medicine bottles, for example, without causing any damage. At the same time, the high-resolution camera and computer vision systems locally process barcodes, monitor inventory in real time, and validate payments in just a few seconds, reducing reliance on the cloud to speed up the entire store operation. But the fact is, keeping a store running involves much more than just moving products, doesn't it? The real challenge lies in interacting with us human beings. That's why Galbot integrated effective computing algorithms, which are able to interpret the context of the conversation, adapt, compare service, and converse in several languages in a way that's almost natural. According to the company, this pilot unit has significantly increased the flow of visitors to this region, serving as a showcase for a much bigger plan. Galbot says it plans to install more than 100 capsule-style stores in major urban centers in the coming months, transforming small commercial spaces into units capable of operating 24 hours a day, 7 days a week with minimal infrastructure and operating costs much lower than traditional models. In other words, goodbye to human attendants, human managers, and other jobs in this sector. Robodega, the name says it all, right? Robodega shows that physical AI has already started to occupy the most common spaces in our daily lives. My friends, what about you? Tell me, so would you feel comfortable being served in a store that's entirely run by robots? If you enjoyed this episode, leave a like, make sure you're subscribed, and click one of the 2 suggestions on your screen. I'll see you in the next one. Just click, and I'll wait for you there. Thanks, bye.